Assalamu alaikum. How are you today? Today we are going to study the mechanic unit 2 for the grade 11. Now in this unit, as you know that mechanic is a branch of physics that studies the motion of objects and the forces that cause or change this motion. It provides that fundamental principles needed to understand how and why bodies move from smallest particle to a planet and stars. As you know, mechanic, as we mentioned in the classroom, mechanic is divided into two main parts: kinematics, which describe the motion without study the cause, and dynamics, that study the motion with referring to the cause. Here in chapter 7, we will study motion of a particle in a plane, kinematics. Kinematics will study motion without referring to the cause that establish it. We have many historical period for the mechanics. In his quest knowledge, man has tried over the year to understand the motion of moving body, and especially the motion of celestial objects, planets, stars of the universe. After that, Galileo Galilei established the law of free fall of bodies and announced the principle of inertia, which is essentially basis of mechanics. Then Newton put the three laws of mechanics: first law, second law, and third law. But in 1905, Albert Einstein say Newtonian mechanics was proven to be limited. It's study the motion for the object, but not for the particles that found inside the atom. So Albert Einstein triggered a revolution in the classical notions of space and time, a new mechanics called relativistic mechanics, which represent the major theoretical breakthrough of the 20th century was established. فإذا عندنا كان Galileo Galilei, then Newton, then Albert Einstein. Now, in this chapter 7, we will study many objectives. We will study the chosen reference to study motion and define the trajectory of position vectors and the displacement vectors of motion, represent the velocity and the acceleration vectors, give the tangential and the normal acceleration uh, and their component. The relation here we will study or not, we will see. Okay. Now, in this chapter, the first objective, we will define the position vector. First of all, as you know, in the 10th grade, you study the motion for the object in one direction, and you study only rectilinear motion. But in this year, we will study the motion in a plane, and the particle will move along x-axis and y-axis. Each particle in its motion has two coordinates, x and y, and this is the origin. This is the origin O, and the particle is called m. The If we join O with m, this is called the position vector of m that vary with respect to time. We say that it's r of t, and we represent r of t. Then at this instant, the particle will be here and r of t. Okay, this is r1, this is r2, etc. Okay, a particle m here has x3, y3, here we have x2, y2. Okay, each instant the particle take a new position and has new coordinates. So we represent the position vector for a moving particle as r of t equal xi z plus yj. Example, this is a moving particle along this trajectory at this instant at point A, at this instant at point B. We join O with A, we get R1 of A, and here we have R2 of A. From A to B, delta R is called the displacement vector for the moving object. Okay, now we'll take an example to calculate the displacement vector AB, يعني to get the displacement x2 minus x1 I, y2 minus y1. How? We say that if AB equal as displacement vector delta R, يعني RB minus RA. Okay, the R of B has XBI plus YBJ minus into XAI plus YAJ. Then we get this result XB minus XA into I vector minus or plus YB minus YA into J vector. This is the displacement vector AB. Okay, now we make an application about the displacement vector. Here we have R of A, the position vector of point A. R of A equal 5A plus 3J, R of B equal 2I plus 2J. How we get this result? I will perform it. Look here, delta R is equal to RB minus RA. Okay, now RB minus 3I minus 1J RA, sorry, RB, sorry, now RB 2I plus 2J RA minus into 5I plus 3J. Okay, make expand 2I minus 5I plus 2J minus 3J. We get the result here minus 3I minus 1J. Okay, now you know how we get the displacement vector between 2 points. If you have the position vector for each point, you can get the displacement vector. فإذا هو is the difference between all time delta means difference between two quantities. Now we are going to parametric equation. Each position vector has x and y. X and y are said to be parametric equation of motion x and y. And the teacher asks you, you have a position vector, for example, r of t equal 3ti plus 40 square plus 2j. Write the parametric equation. Write the parametric equation. Okay, equations. Okay, here the quantity which is multiplied by I here x equal 3t. The quantity that I multiply by j is y equal 40 square. Very simple. Okay, plus 2. You can write it all directly. Okay, now distance lead displacement vector d هي radical شو x square plus mean plus y square. We write it 3t over square plus into 40 square plus 2 all of it square. You can expand or the teacher asks you to determine the position at t equal 1, at t equal 2, etc. Okay, now here in this example the displacement vector since x equal 2t square minus 3t plus 1. If the teacher asks you where is the particle, for example, where is the particle at t equals 0, at t equal 0, we write r of 0, not r of t, r of 0 equal 2 into 0I plus into minus 3 times 0, and we replace t by 0 plus 1 j. Clear? We get 0I plus j, يعني the particle at point 0, 1 in the plane. Okay? The teacher said at t equal 1, at t equal 2, anything. Okay? Get the radical for all quantity. Okay? Now we are going to equation of trajectory. What we mean of equation of trajectory? In this yearly trajectory has many types, and a trajectory may be straight line, may be curve, may be circle. Now, is the relation between x and y independent of t? How we get it? First step, keys. Okay, to answer. We get or we write x equal, for example here 2t. From x we get the value of t, equal x over 2. We replace it in y, replace t in y, so y equal minus 3t plus 1. Do you know why I write the parametric equation? يعني to get the equation of trajectory. So we have minus 3 into x over 2 plus 1. This is the equation of trajectory, يعني minus 3x over 2 plus 1. Here the relation between y and x. If the relation between types of trajectories, when the relation between x and y, trajectory straight line as here. Okay, when the relation between y and x square the equation is curve, parabola, hyperbola, I don't know. Now, if the relation between x square and y square, the trajectory is a circle. فإذا how many type of trajectory we have? Straight line, curved line, and circle. How we identify it? When we find the relation between x and y only, so we say that the equation is a straight line. If the relation like this, y equal مثلا 2x square plus 4, the relation between x square and y, we say that the equation is curved. When we have مثلا x square plus y square, for example, equal 4 or equal 0, the relation between x square and y square, say that the trajectory is a circle. Clear? Now we are going to where definition for instantaneous velocity of a particle. Instantaneous velocity of a particle. Uh, Instantaneous velocity for a particle, and as you know, the velocity uh, at a given instant here. ماشي الحال. How we get at to get the relation velocity? We say that v equal r prime. What we mean by r prime here? Derivative for r. Derivative for r. We mentioned in the classroom all rules of derivative. Okay, all rules of derivative. And derivative is the variation of function with respect to another function. يعني first one, when y equals say x to power n, we say y prime, use the derivative is equal n x to power n minus 1. Example, y equal, for example, 2x square, y prime equal derivative of 2. هلا 2 الباور اللي هون we put it here, x 2 power 2 minus 1, we get 4x to power 1. هذا الدerivative. اوكي هذا rule. But derivative of function 2 إذا كانت الفانكشن constant y equal a يعني constant, y prime always equal to 0. يعني if y equal 4 يعني y prime equal to 0. هذا derivative لإلها. هلا في عنا derivative for what also? Derivative for sin y equal a sin u. y prime equal a time u prime cosine u. Okay, for example, y equal, this is the third law, y equal مثلا 3 sin 2t. فإذا هاي ال A وهاي ال U صح؟ ال A equal قديش؟ 3. ال U equal 2t، يعني ال U prime equal 2 صح؟ فبنعوض هون y prime equal 3 time 2 cosine 2t as it the angle not change. Okay. The fourth rule y equal a cosine u. إذا y prime equal a time u prime derivative للكوساين minus sin u. Okay. Minus sin u. Example y equal 2 cosine 5t. y prime equal 2 time اليو برايم قديش هون 5 تي اليو، يعني اليو برايم 5. الديريفيتيف للكوساين minus sin 5t we get how much minus 10 sin 5t. ليش بناخذ derivative? Why we need derivative rules? To get function from another function. I mentioned it in the classroom and we make examples and exercises. Okay, here we have velocity equal v، يعني ال r of t equal for example اللي اخذناه الاكزامبل اللي قبل ال r of t equal r of t كان عندنا بيساوي here r of t equal 2t plus 3 2ti plus 3t plus 1j. Okay, now to calculate the velocity vector هذا ال r vector velocity vector هو r prime of t. شو بنعمل؟ derivative لأول وحدة ل 2t هي 2i. الديريفاتيف للتاني واحدة للسكند 1 3t plus 1 هي 3j. فإذا هاي بتصير اسمها Vx وهي شو بصير اسمها Vy. To determine the magnitude of the velocity يعني السبيد، speed هي magnitude هي Vx square plus Vy square. فإذا under radical فإذا V equal 2 square plus minus 3 square. Sorry, here we have minus sign, here we have minus sign. Okay, فإذا بيطلع عنا derivative اللي بيطلع عنا ال velocity and its speed. يعني to determine the velocity we make derivative for the position vector. To determine speed we make a radical for Vx square plus Vy square.